Hello, and today's learning target is I can solve equations with variables on both sides. Let's take a look at the first example. I see negative 14 plus 12x equals 8 plus 11x. I want to get my variables on one side, and I'm going to move them to the left-hand side and move my numbers to the right-hand side. So if I move this 11x over, I'm going to subtract 11x to both sides, and then what I get is negative 14 plus x equals 8. And now I'm going to move the 14 over, so I'll add 14 to both sides. And I get x equals 8 plus 14 is 22. So x equals 22 is my answer. And then to check my work, I could substitute 22 back in for x here, and plug that in, and then double check my work on my calculator to make sure that this holds true. And when I check my work, if I have negative 14 plus 12 times 22, that better equal 8 plus 11 times 22. And negative 14 plus 12 times 22 comes out to be 250, and 8 plus 11 times 22 comes out to be 250, so we know that we're correct. And that was by checking our answer. Let's take a look at the next example. So again, I want to get my x's on the left-hand side and my numbers on the right. So I'm going to add 11x to the left-hand side. And I could at the same time, get rid of this negative 95, but I'm just going to go step by step. And I have negative 95. Negative 5x plus 11x is plus 6x equals 61. Now to undo this negative 95, or the inverse operation, is I would add 95. And then I'm left on the left-hand side with 6x equals 61 plus 95 is 156. Last step would be to undo a multiplication problem with division and get x equals 26. Now, reminder, you could plug your answer back into your original equation here to check your work, and I strongly encourage you to do that. Take some time to do that on your own. However, I will go to the next problem. Okay, let's continue on. I am going to move my variables again over to the left-hand side, and it really doesn't matter what side I put them on as long as the variables are on one side, the numbers are on the other, but I like to put them on the left-hand side. So I'll add 10x. Negative 7 plus 10 is positive 3x. And then I still have the minus 41 equals 49. I'll isolate my variable x by adding 41 to both sides and get 3x equals, and 49 plus 41 is 90. And last step would be to divide by 3, so x equals 30. Again, as a reminder, please feel free to plug in that number back in for where you see x into the original problem to double check your answer. Okay, I'm going to get my x's on the left-hand side, so I'm going to subtract 8 from both sides and get negative 87. Move that over. So negative 87, 3 minus 8 is negative 5x equals 23. Then I'll add 87 to both sides. And now I have to bring down the negative 5x equals 23 and 87, give me 110. Last step would be to divide by a negative 5. And 110 divided by negative 5 is negative 20. Oops, hold on. 110 divided by negative 5 is negative 22. 100 divided by negative 5 would be negative 20. So x equals negative 22, and then that is my final answer. So again, please make sure you took the time like we did in problem 1 to plug your answer back into the original equation to check that you got it correct. All right, let's get a little bit more practice with going through some examples. Okay, so again, we want to get the variables all on one side and then to isolate the variables so we can solve for x. So I'm going to subtract 9x to both sides and get 6 minus 9x is negative 3x minus 51 equals 32. I'll add 51 to both sides, so that can allow me to isolate my variable almost. And 32 plus 51 is 83. Last step would be to divide by a -3. And I get an answer that comes out to be decimal. So what I'm going to do is I'm going to leave my answer in fraction form, but I'm going to change this improper fraction to a mixed number. So I know my answer will be negative because it's 83 divided by a -3, and 3 goes into 83 27 times. And 3 times 27 then is 81. So what's our remainder then to get to 83? 2, and then my denominator here is 3. So my answer will be -27 2/3. Or if I did write it as a decimal, that is -27.6667, which is the decimal for 2/3. So it'd be 27.67 repeating. All right, let's look at the next example. I, again, want to isolate my variables by getting them all on one side. So I will add 3x to both sides and get -60 plus 9x equals 48. And then I'll add 60 to both sides. And I'm left with 9x equals 60 plus 48 is 108. And 108 divided by 9 is 12. So that one comes out to be an integer value. Great job following along. Just a few more examples left to go. All right, so let's add 9 to both sides, 9x, excuse me. And I get -3 plus 9x is 6x minus 46 equals 80. Add 46 to both sides, and 6x equals 80 plus 46 is 126. And then the last step to undo 6 times x would be to divide by 6, and x equals 21. Okay. I am going to, on this example, subtract 12x. Again, I want to combine my x's. So I'm going to move them to the left side, and I'm left with -60. 7 minus 12 is -5x equals 45. Okay, I want to isolate my variable x, so I'll undo this -60, and I'll add 60 to both sides. And when I add 45 and 60, I get 105. But then on the left-hand side, I have to bring down the -5x, divide by -5, and x equals -21. So in summary, to move a term with a variable to the other side, you need to do or complete the inverse operation. And then combine like terms. So again, like terms are variables that have the same exponent. So 3x and -5x, or we could even say other variables are like terms like 10y and -22y. So again, we want to combine like terms and get them all on one side, and then solve that equation for that variable. Thank you for listening. Have a great day. Bye.